forgot to start from the beginning. So right now, students are working on their class assignment. It's called Acceleration Explore. Just ignore me, period 5. I apologize. We looked at this slide here where we have 3 possible examples of which one do you think represents acceleration. So is it A, B, or C? Fifth period took a survey and a vast majority of them picked C. Next was A, and then 2 people picked B. But in reality, all 3 of them are examples of acceleration. So now we're going to look at acceleration. Thank you, John. And the first question, let me show the worksheet. The first question is to define what acceleration is. So you're going to do a search. You're going to find a reputable source. Wikipedia is not a reputable source. You want to see who the source is, and we want it to be science-related website, okay? Make sure you cite your source so you can copy and paste the link directly from where you are. And then in the examples, why are each of these 3 examples? So once you have your definition, then now apply it to these 3 examples. Just if you're not sure, try something. Don't just sit here, okay? And then last but not least, do a quick search. What are the units for acceleration here, okay? So we've been doing this for 5 minutes now. In the chat box real quick, how much more time do you think we need to finish? Write, if you can, it's better to write your own definition. Okay, it looks like a few minutes. Some of you are done. If you're done, then just be patient, please. We're gonna give 3 more minutes, okay? Two more minutes. I'm gonna go ahead and pause the recording. Remind me, 5th period. We are going to now share your, what if you submitted already but didn't write down your own definition? You should be able to open it. Let me see. Acceleration, period 5. And allow edits. Okay, you should be able to open it now. I just opened it up. For number 6, it's going to be just do a quick search. What units for acceleration? So participation again. Who would like to share their definition for acceleration? Again, as we're going through this, if you find that you need to make corrections to yours or you want to add to yours, you may do so. Okay. So let's see. Sydney, what was your definition?
Is the extent of change of velocity.
Okay, change in velocity. Thank you. Ethan, what was your definition?
Definition was increase in speed and velocity.
Okay. Kristen, what was your definition?
Mine was when object changes velocity.
Can you say it again louder, please?
Mine was when an object changes its velocity.
Okay, thank you. Jazzy, what did you get?
I put acceleration is the rate at which velocity changes over time in terms of direction and speed.
Okay, good. Fernando, what did you put?
I put an object is to change its when an object is to change its velocity.
Okay, good. Now, I want to remind you that velocity is speed with direction. Okay? So there's 3 ways that velocity can change. Let me clear your hands. Acceleration is a change in velocity over time. Give me one way. There's 3. Give me one way that velocity can change then. Sanal, give me one way.
By change in direction.
We can change direction and be accelerating. What else could we do, Naomi?
Change the speed.
Louder.
Change the speed.
Change the speed. Is it only getting faster?
Faster or slower.
Faster or slower, okay? So when we talk about acceleration, acceleration is a change in velocity over time, meaning you can go faster, you can go slower, or you can change direction. So I know that when you hear in like commercials, especially when they're trying to sell a car, right? Oh, this car accelerates to 0.60 in blah, blah, blah seconds. You're like, ooh, wow, that's fancy. And so usually when you hear acceleration, it's how fast something can go. But in physics, it's more than that. It could slow down or it could even change direction. So now somebody help me out here. How does this first example, why is our A person here, this scenario, how is this an example of acceleration? Alexander, how is A an example?
It's changing its direction.
Exactly, right? It's going the same speed. It's not speeding up or slowing down, but the direction is changing. Thank you. Part B. Can I get some new voices? I've heard from all these people. Here's your 5 points for the week. How is B an example of acceleration? Sanal, how is B?
It goes slower.
Going
as well.
slowing down. And then Miley, how is C an example of acceleration?
C is an example because it's getting faster.
Louder, please.
C is an example because it's getting faster.
Because it's getting faster. Remember, these 3 things are the definition of acceleration. So we're changing direction, we're going slower, and then we're going faster. We have a change in velocity over time. Did anybody find the units for acceleration? Anybody find the units for acceleration? Sharon, what did you find?
Meters per second squared.
Okay, so let me show you. View responses. Let's see if you guys were able to do that. So in the box, let me log out. Oh, here we go. Meters per second squared. Let me show you how to do that as a student. So I need to change my account. What the heck was that? And then we have here. So when I do my acceleration explorer, I can go down to number 6. Oh, you know what? Because I have my little keyboard, my wireless keyboard, I keep pushing on it. Well done, Miss King. Okay, so if I hit that blue plus sign and I click math, I'm gonna click on that equation again and delete it, gone. Now I'm gonna put M for meters, backslash, SEC for seconds, and I'm gonna use this X, you see the little 2 floating on top? So it's on the top level to the right, and it's gonna square the seconds for me. That math function helps make things very pretty for us, okay? All right, any questions for me? All right, if you are happy with your worksheet, then you can hit submit and go ahead and go back to Google Classroom and click done. It is time for us to take our second break. So go ahead and get up and stretch out, get something to eat. As well. So again, we've been talking about acceleration. Acceleration is a change in velocity over time. A lot of us are used to thinking of it as only speeding up, but it's more than that in physics. It could be slowing down or changing direction as well, okay? You also saw some units for acceleration. Now, if we were in person, I would actually have you do some calculations with me, and we would calculate the acceleration of various objects, and we would find how fast they were slowing down or how fast they were speeding up over time. But it's pretty challenging. In person, I would be able to walk you through it. Online, it's a little bit more challenging. So this year, you are not required to calculate acceleration. However, you need to be able to recognize the units and understand where they come from. Like, why did that come about? So to help you with that, I have a brief video. If the video goes kind of crazy for you because of the internet, don't worry. I'm going to post these slides and this recording after class is over on Google Classroom. So you'll have both resources for you, okay? So again, a little review. Going backwards, here we go.
When we are in a stationary car that moves rapidly to gain speed, we get pushed back against our seat. And when brakes are applied, we get pushed ahead. Or when we take a sharp right turn, we're pushed towards the left. These are all situations where we are accelerating. We have all experienced this, whether in a car or a bus or while riding a motorbike. Simply put, when velocity changes, we have acceleration. I still haven't defined what acceleration is. I just told you that when velocity changes, there will be acceleration. Okay, let me give you 2 examples. In the first one, a car is traveling in a straight line at a constant speed of 80 kilometers an hour. And in the second one, a plane is traveling in a straight line at a constant speed of 1000 kilometers an hour. In which case do you think acceleration is involved?
Which one?
None. In both cases, the velocity is not changing at all. Hence, there will be no acceleration in either of the cases. Most people relate acceleration to high speed, and that's clearly not true. Acceleration will only exist when there is change in velocity. Do you remember what velocity is? It's speed with direction, and it's hence a vector quantity. Why is this important? Let's say a body moves from rest and reaches a velocity of 20 kilometers an hour in 5 seconds. Will acceleration be involved here? Yes, because the velocity is changing. It was 0 initially, and at the end of 5 seconds, it's 20 kilometers per hour. In another scenario, assume that a body is moving at 30 kilometers an hour, and then it moves right at 30 kilometers an hour and continues traveling at the same speed of 30 kilometers per hour.
Hold on.
Will there be acceleration in this case?
Is there acceleration? Yes or no? Yes or no?
The answer is yes. As the direction is changing, the velocity will also change. The only thing constant in this example is speed, but the velocity changes as the direction changes. So this was the most important concept you had to know about acceleration. It will exist only when there is a change in velocity. But how is acceleration calculated? Acceleration is defined as the rate of change of velocity. In terms of a formula, acceleration can be written as change in velocity over the time taken. If the velocity of an object changes from an initial value of u to the final value of v in time t, then the acceleration a can be written as v minus u over t.
Now I want to remind you, don't freak out, okay? Some of you are like going to get completely lost and stop watching. We are not going to calculate acceleration this year, but I need you to see how the units come about, okay? So if you're freaking out right now, relax and just enjoy the video.
Say this object is at rest initially at point A. It then travels to the right and attains a velocity of 10 meters per second in 5 seconds. What will be the acceleration here at point B? We can look at the formula to get the answer. The initial velocity u is 0 meters per second as the object is stationary. The final velocity v is 10 meters per second and the time taken t is 5 seconds. Hence, the acceleration a will equal 10 meters per second minus 0 meters per second divided by 5 seconds. So this will equal 10 meters per second divided by 5 seconds. 10 divided by 5 is 2. Wait, hold on. What will be the units of acceleration? We should get a hint by looking at this. The units of acceleration will be meters per second, because it's the change in velocity over the time taken. As this is meters per second, we can carry this second to the denominator, and what we will get is meters per second squared. This one is more intuitive, but this one is a bit neater, I would say. So the acceleration in this case will be 2 meters per second squared. And acceleration is also a vector quantity. Here, acceleration and velocity are in the same direction. There are many more important concepts about acceleration which we will cover in the coming videos.
All right. So again, don't freak out if you totally got lost. Don't worry, it's okay. But I want you to see how we got those units meters per second squared, because you're going to see these units when we do forces next week, and then when we do astronomy in a few weeks from now, you're going to see that meters per second squared, and I want you to not be completely lost, okay? Questions about acceleration? All right, so again, it could be slowing down, it could be changing its direction. Those are also examples of acceleration, okay? If you haven't already, make sure that on that classwork, that Acceleration Explorer, you click Submit on GoFormative, and you have to do 2 things. Go back to Google Classroom and click Done. Several students are not doing this, and you're not going to get full credit if you don't. So make sure you actually do this. I also want to remind you that you have a quiz on Wednesday. And right now, I'm almost done leaving you feedback. So what I want you to do now is go to your formative. So if this, am I a student? Yes. Notice right next to my, my little image, my picture, I have this little notification, okay? When you log into Go Formative, if I left you any feedback, it's gonna tell you right away when you log in. If you did not get any feedback, that means you did everything correct. You're ready for that quiz. If you open it and there is feedback, go ahead and make your corrections. Now there's a few of us that did not finish motion homework number 1. Do that now, okay? We have 10 minutes. And what I want you to do in these last 10 minutes is prepare yourself for that quiz. Look at the feedback for Go Formative. I'm almost done with homework number 1. I will finish homework number 2 today. So if you log on there tomorrow to see your feedback, you're going to see that for number 2. If you already checked your feedback, then go and update your digital notebook. Take these last few minutes to update your notebook and review and study for your quiz, okay? Any questions for me? All right, so we have a few more minutes. Please let me know if you have questions. And I'm literally leaving feedback on every single problem for motion homework 1 that needs to be corrected.